Greetings to Dr. Muhammad Yusuf. So the reason I'm here is to present about course which is BMM 3532 Fluid Mechanics Lab. We are going to discuss about the lab 2 which topic as flow over immersed body and boundary layer theory. Members, I myself Kuglan Hakimaniam M818098 would like to start the presentation. First and foremost is I would like to talk about the introduction. So the background is Ludwig first person to determine the boundary layer effects in the early 90s. He first proposed to interactively couple two-layer solution which properly models many flow problems. This is the diagram of the boundary layer condition. And then when a fluid flows through an object, the object feels a resistant force that makes the object difficult to move on its direction. This is called a drag force. The drag force remains the same whether the body moves through the fluid or the fluid flows around the objects. As the relative motion remains the same. It's the same concept but it's a different action. It's actually the same relative motion. So the second thing is the flow of object not only produces drag force alone, it will also produce horizontal and vertical forces. This even occurs only when an object flows with an angle with it. So this is the picture diagram. Then about the objective, the first thing is to design the complete measurement technique for fluid flow and measure the drag and lift forces applied on a symmetrical aerofoil at different angles of attack. Then to determine the velocity distribution for flat plate. Third one is to determine the boundary layer thickness of a flat plate subjected to longitudinal flow for rough and smooth surface. Then chapter 2 is about the theory. First thing is about to talk about the principle and formula. Then here is stated that on an aerofoil, part of the pressure and part of the shear becomes the lift force. Part of the pressure and part of the shear becomes the drag force. The aerofoil is designed as streamlined body to minimize the drag and to maximize the lift. So this is a common picture. Then continuation about the drag lift and lift force. Flow in a boundary layer may be laminar or turbulent. Among the factors that affect the boundary relation are pressure gradient, surface roughness, heat transfer, body forces, and free stream disturbances. This is the picture. So now I would like to end my presentation and would like to my colleague to speak about the next slide. Thank you.
Next, we go on to the procedure. For experiment 1, which is flow patterns of symmetric aerofoil at different angle of attack. Firstly, we need to set up the experiment as shown in the figure. Next, aerofoil model is then attached and screwed to the airflow bench. First, the experiment starts with 0 degree angle of attack. Then switch the turn on and the radial fan to allow it to move. The radial fan speed controller is adjusted at the initial speed of 12. Next, the readings are recorded and tabulated. The smoke controller is then pressed to emit smoke into the flow to view the flow of air on the aerofoil. The picture of the flow of aerofoil is taken, and then the radial fan speed controller is then increased by 1 until the speed of 19. Lastly, the experiment is repeated from step 5 to add for 30 degree and 45 degree. Next, for experiment 2, which is flow over flat plate. The experiment is also set up as shown in the figure. The smooth surface flat plate is inserted into the airflow bench. Then, the first distance is taken as 0 and the following distance taken. The pitot tube is connected to the vernier calipers. Next, the pitot tube is first touched to the surface of the flat plate as the first data. The radial fan is then turned on and data are recorded and tabulated. Next, the distance of the plate is taken from 0 mm, increased by 20 mm until it reaches 140 mm, while the pitot tube distance from the surface of plate is taken from 4 mm, increased by 4 mm to 32 mm. Lastly, the experiment is repeated from step 5 until 7 for the rough surface.
Okay, Assalamualaikum warahmatullahi wabarakatuh and a very good evening. My name is Amirul Nawaf bin Isa and my ID is MA17222 and I am from Bandar Sunway, Subang Jaya, Selangor. And today I will be discussing about chapter 4, which is results. Next, I will talk about experiment 1, which is the flow pattern of symmetrical airfoil at different angle of attack, which is the flow over immersed body, with varying attack angle and varying speeds. For the varying angle, we'll be using angle of attack of 0 degree, 30 degree and 45 degree. And for the fan speed, we'll be using 12, 13, 14, 15, 16, 17, 18 and 19. So all of the data is recorded. Next, I will be talking about the angle of the calculation for point 1, which is how we find the difference of head. We'll be using the formula initial head minus head, which is the parameter for the initial head is 137 millimeter, minus the observed head, which is 135.5 millimeter, and the difference in head is 3.5 millimeter. And next we will be calculating the velocity v using the formula of square root 2 times gravity times difference of head. So plugging the data and the numbers we will get 0.26205 meter per second for the velocity. And the calculations are repeated for the other fan speeds and other attack angles using the above formula. So next I will be talking about the angle of attack. Here we will be talking about the lift force and the drag force calculated using Excel, so it will be easier for us. And this is the result. And this is the calculation. The example is for point 1. So the formula for lift force is stated here, and also for the drag force is also stated here. We'll be using the coefficient of lift and the coefficient of drag using the formula here, and we'll get the results. Next, this is the graph for the lift force versus fan speed and also the drag force versus fan speed. And for both of these graphs, we can say that as the fan speed increases, the lift force increases and also the drag force increases. So next I will talk about experiment 2A, which is smooth surface flat plate, and we will be using the plate distance of 0 increments of 20 millimeter from 0 until 140 millimeter, with a boundary layer thickness of millimeter of 4 until 32, with a varying difference in 4 millimeters. And this is the data collected. Next, this is the boundary layer thickness and the calculation for the difference in head is the same as before. We'll be using initial head minus head, which is 278 millimeter. The parameter stated it will be 278 millimeter minus the head is 257 millimeter, and we'll get 21. And this is the difference in head, and we'll be using it for every point, the same calculation formula. Next, this is the graph generated for the head difference versus boundary layer for smooth surface. We can see that the data is close to each other and it's quite smooth. Next, this is the calculation for velocity. We'll be using the formula of square root 2 times gravity times difference of head. Next, this is the graph generated using Excel file for velocity versus boundary layer for smooth surface. We can see that it increases steadily, and at the end it kind of decreases a little bit. This means that there is an upper limit for how fast the velocity is, depending on the boundary layer thickness. Next, I will be talking about the calculation for the Reynolds number using the formula of density times velocity times length over coefficient, and here we will get the results, and the calculation is done for every single plate distance and every single boundary layer thickness. Here is the graph for both Reynolds number versus boundary layer for smooth surface and the velocity versus distance for plate for smooth surface. Next, I will be talking about experiment 2B, which is rough surface flat plate. Before this is smooth, now we'll be using rough surface, and there is a difference in data collected. As you can see here, this is the data collected, and here we'll be seeing how to calculate the difference in height. Is the same as before for the smooth, however there is a difference in the value for difference of height. And here we can see the graph for the head versus boundary layer for rough surface, and noticeably we can see that the graph here for the rough surface is quite erratic compared to the smooth surface. This is due to the different coefficient. Next, here you can see this is the calculation for velocity. It will be the same as the smooth surface, which is square root of 2 times gravity times difference of height, and it is done for every single plate distance and boundary layer thickness. And here is the graph for the velocity versus boundary layer for rough surface. For the smooth, you can see that for almost each of the plate distance is quite close to each other. However, for the rough, there is noticeable gaps between them. However, they are still increasing steadily. And here is the Reynolds number. This is for the rough surface. It's still the same. However, we can see that the Reynolds number here is higher compared to the smooth surface, as it is the rough surface causes more disturbance in the flow. And here we can see the graph generated for both Reynolds number versus boundary layer for rough surface and the velocity versus distance of plate for rough surface. You can see that the velocity is quite there's a quite a large amount of difference between the 4mm boundary layer thickness compared to the others. This is due to the rough surface at low speeds and low plate distance. And that is all from me. Thank you.
Yeah, Assalamualaikum warahmatullahi wabarakatuh. Okay, for the conclusion, this chapter will discuss the relevant details necessary to deduce a conclusion regarding this experiment as best as possible for each of the experiment that have been done by us. Okay, for experiment 1, flow pattern of symmetry effort at different angle of attack. The wind stream profile over an aerofoil produce distinct streamline design at different point of attack. When all considerations are taken into account, we can infer from both set of data that lift force and drag force rise gradually with fan RPM. When the two diagrams of are coordinated, lift force exceeds drag force at both fan speed and angle attack. When the two diagrams are matched, lift force outnumber drag force at both fan speed and angle of attack. We can say that in short, the different angle of attack has an impact on the lift force and drag force. Okay, so we continue conclusion for experiment 2, which is smooth surface. Based on all the result of experiment 2A, we can safely deduce from the graph that height difference increase gradually with boundary layer thickness, while when comparing graph and table, height difference decrease as plate distance increase. Following that, as the thickness of boundary layer grows, velocity increase gradually. Meanwhile, the velocity
decrease as the plate distance increase according to the data in the graph and table. Okay, as the thickness of the bond layer increase, the Reynolds number rise gradually, and the graph and table show that the Reynolds number increase proportionally with plate distance. In general, we can say that the smooth surface has a constant result of increase due to its coefficient not being the way as much. This is good for application that require less drag and place an important speed string. Okay, so lastly for experiment 2B, which is rust surface, based on all of our studies, head difference increase gradually as the thickness of the boundary layer increase, and based on the graph and table, head difference decrease as plate distance increase. With the thickness of the bond layer, the velocity increase gradually. The velocity decrease as the plate distance increase, as seen in the graph and table. Okay, according to the graph and table, the Reynolds number rises gradually as the thickness of the bond layer increase, and the Reynolds number increase proportionally with plate distance. Finally, the plate distance has an inverse relationship with velocity. In conclusion, a smooth surface has a higher flow velocity. Finally, the plate distance has inverse relationship with velocity. Okay, in general, from this experiment, we can say that the rough surface of the object has a tendency of getting erratic result, thus not having a proper constant result in data. This conclusion is obtained from the understanding and noticing the pattern in the graph generated.